Hello, my name is Brad Parker with SureFi, and I wanted to do a quick little video because I've had a lot of questions on the difference between OSDP and Wiegand. And we've recently released our SureFi Access Pro, and just to jump over to our website, this does Wiegand and OSDP. It has both inputs there. And we've had a lot of questions on, well, what is OSDP? And I decided to jump on YouTube and just find a quick little video. Just searched Wiegand versus OSDP, and just this very first video. I just wanted to watch it, and we'll go through it, and I'll give you my opinions and thoughts on what he says.
Hi, Mark McRae here for In-Access Security Systems. Now I'd like to go into explaining a little bit the connection between a reader and an access control controller. So that is done via wire, of course. So these are wired in between the controller and the reader. But there's two different ways to connect.
SureFi offers wire replacement. So instead of trenching or running conduit between those card readers and the access control panel, you can mount a SureFi near each side, wire into our bridges, and go wirelessly.
There's two different ways to connect between a controller and a reader. For years, since, as long as I've been in the industry for 35 years, there's been a communication protocol or a way to communicate between a reader and an access control controller that's called Wiegand. What these readers do is they are at 5 volts all the time, and when there's a read, it will drop down to 0 volts, which is also called a bit.
Wiegand transmits data over 3 wires. There is 5 volts DC between the ground wire and each of the data wires. The Wiegand devices transmit the unique credentials to the access control panel in a series of zeros and ones, like he said, are called bits. The most common bit rate for Wiegand is 26 bits. Bits are sent by the Wiegand device by quickly vacillating the voltage on the green wire, or data 0, and the white wire, data 1.
And if you have the right equipment, you can actually read this change of voltage off the back of the wire. Then I can reproduce that change in voltage to copy a card or to imitate a card.
He is right if people can get access to those wires. What SureFi does, though, we take that, send it wireless. And our radio, we AES encrypt it. We do channel hopping, so every time it's on the air transmitting, we roll the code, and we're only on the air for a few milliseconds. It makes it very elusive, and so on our SureFi device can encrypt that and make that more secure.
A group of companies created a new standard called OSDP, Open Supervised Device Protocol, OSDP. OSDP actually uses as a communication layer, the RS-45 standard.
As more and more companies using this OSDP standard, we have created a bridge that is also compatible with OSDP, has OSDP inputs. It also has Wiegand inputs on it as well. It has that same encryption that I talked about with the AES 128 bits, the frequency hopping using the chirp so it's on air for a short amount of time. Our Access Pro bridge replaces that wire with Wiegand and also with OSDP. Also adds another layer of encryption on top of just the OSDP if it was hardwired that he is talking about.
Everybody who's doing a system now, if you're doing a new system, we definitely suggest that you go towards OSDP readers and OSD communication protocol. That way you can have an end-to-end encryption from your card all the way to the keyboard where the operator is using the system. Hopefully that was clear.
Awesome. So thank you, Mark, for explaining the difference between Wiegand and OSDP for us. Hopefully that gives you a little bit of an idea of the differences, and also how SureFi can replace that wire, remove the least favorite part of your job, which is trenching and running conduit, pulling wire, can add an extra layer of security with the Wiegand and the OSDP in going wireless with the AES 128-bit encryption, and also the chirp modulation, the hopping tables, and just the time that we're on the air. Hopefully that was informative, and thank you for watching.